All right, so thank you very much, Professor Ganguly. Thank you very much, Heinz, for giving such a wonderful introduction to this environment here, and I'll try to do it justice from the European Patent Office point of view. So, talking about the Fourth Industrial Revolution, of course, the first question is, what is the Fourth Industrial Revolution? And I'll just go very, very quickly over that. I think everybody has seen these diagrams where people talk about the First Industrial Revolution with coal and steam and so on, and the Second Industrial Revolution with electricity and oil, and the Third Industrial Revolution with computers. So what is the Fourth Industrial Revolution? And for us, it's connectivity. So connectivity is the one new thing that really defines the Fourth Industrial Revolution. It allows very, very complex simultaneous systems, such as a whole motorway of cars driving down the motorway and all being intercontrolled and so on. It will also allow very, very complex supply chains to be interlinked, with sensors, with information being transferred from one company to another, with an order being transferred right down the supply line and already indicating to raw material suppliers what you might need for some components that will come later in cars and all that kind of thing. So connectivity is the thing that defines the Fourth Industrial Revolution for us, and we'll elaborate a little bit on that. Now, what does the Fourth Industrial Revolution mean for the IP system? For us, one of the biggest impacts that we've seen is the increase in information and communication technologies in every single area of technology. So once upon a time, computer programs were very isolated things. These days, computing is in absolutely everything. And you'll see the trends here in the patenting world that back in 1998, maybe 36% of the inventions were ICT related in the automotive area, and these days it's 63. That's a massive change, and that change is simply continuing. In medical technologies over the same timeline, it's gone from 1/3 to 1/2, but we see this in every single area of technology, also in chemical processing, biotechnology, diagnostics, everywhere. So computing is everywhere these days, and the biggest impact on the Patent Office is we simply have to cope with this. Now, the underlying technologies of the Fourth Industrial Revolution are, as ever, hardware and software, but now it's interconnectivity between all of those devices and systems as well. This is, however, being greatly accelerated by the new possibilities of the emerging technologies. So the big data that is produced by sensors being absolutely everywhere is too much for manual reprocessing and optimization of the systems. So you need things like artificial intelligence to cope with the big data, automated machine learning, which continually themselves re-optimize the systems according to the goals that you give them. We'll have blockchain, which will control the supply chains of food and medicine and frozen goods and many other things like that as well. 3D printing or additive manufacturing, and many other emerging technologies which greatly enhance the capacity and the ability to change systems with the Fourth Industrial Revolution. And what this results in then is what you hear so often: smart domains, smart health, smart buildings, smart cities, where the sensors are gathering information, the systems are interconnected, and through the connectivity, we're able to continually optimize and re-optimize these systems. And one of the things I think we enjoy a lot is things like Uber, combining the GPS with ordering a taxi. In Munich these days as well, you have very many cars which you're able to simply pick up on the street. You can find the next car, you go to it, it unlocks itself when you've activated it, you pay automatically for the car, and we're so much more car sharing now in Munich than we used to. And another thing is that all the trams, the buses, the underground and the trains, they're all interconnected. We know when one's coming, and the app will simply give you the best and fastest route from where you are today or this second to where you want to go using the public transport. These are already proving to be absolutely fantastic, and these kind of things are improving all the time. So is the Fourth Industrial Revolution real, or is it just hype? What we do is we use our patent statistics to be able to map trends. And we talked about the core technologies, we talked about enabling technologies, and we talked about applications, smart applications. So all of these are based on connectivity, and you'll simply see in the last 5 years that the inventions in these areas are simply increasing exponentially. And therefore that is our undisputable evidence that the fourth industrial revolution is real. And it is, there aren't just a few examples of it, it really is taking off in a big way. And there seems to be no limit to this. Just another example, looking at the number of applications we get for smart objects, you'll see the same kind of patterns following there. So when we defined the European Patent Convention 40 years ago, computing was very much isolated, and the rules were simply that computer software could not be patented as such. However, with computing in every single area, and very often the inventions being in the algorithms or whatever, we have to cope with that. So we've developed the concept of computer-implemented inventions. It's very, very similar to the computer-related inventions in India, and that means that you can patent a computer-implemented invention if it solves a technical problem and it is a technical solution to that technical problem. So we have the two-hurdle approach. Firstly, does the invention have a technical character? That's usually very easy. Does it have a processor? Does it have memory? Does it have a network and so on, and other technical aspects? But the important thing is, in the inventive part of the invention, in the defining features, in the claims and so on, are they a technical solution which bring about a new and inventive technical effect? And my colleague, Georg Weber, at the front here, will talk about that later on in the session this afternoon. So it's best if I don't go into detail about that myself here. But that is the defining factor. That is the procedure that we use absolutely everywhere. Now, this understanding of computer-implemented inventions is now vital throughout the entire patent office. We're using our 3-person examining division on every patent to often combine people from different technical areas. You could combine somebody in an ICT area with somebody in a biotechnology area and a chemical area to look at a relative invention in the biotechnology field. And we've restructured the entire operating patent examination area to reflect this. We have annual improvements to our CII guidelines. The ones that came out at the end of last year are coping in particular with artificial intelligence as a result of the work we did last year, and we're constantly improving these guidelines, which are publicly available on our website, to be able to guide applicants on how to work. And we focus the CII training throughout all the technical areas these days as well. So we use our patent, our 100 million documents that we have in our patent databases. We use these to map these trends. You've seen the results from the fourth industrial revolution. We have another report on our website on self-driving vehicles, and you'll see again over the last 5-6 years the patents on self-driving vehicles have increased by over 300%. It's another absolutely convincing statistic to show the way these things are going. So, where do we go here? Well, we've got software, but we're now moving to artificial intelligence. We're moving to self-optimizing super software, and this is going into every single field of technology. That's what we're having to cope with. What we had last year was a series of conferences where we had scoping workshops with applicants. We had workshops where we looked into detail about how they wanted to draft claims to protect their inventions and what we would accept as clear, concise, novel and inventive. And we produced those results on a conference on patenting with artificial intelligence on the 30th of May. We had a second one on patenting blockchain, then on the 4th of December. That was also including representatives from MasterCard, your colleague Sean, as well. And we're developing the inventivity, the two-hurdle approach. I mean, as Heinz said, there's nothing fundamentally new there, but we're having to still refine this with the grey areas of, do we patent algorithms, do we not? Do we patent different types of architecture in artificial intelligence? What about the machine learning techniques and the results of those? The same with blockchain as well. So we're refining exactly what we patent, trying to make that public. And in the Indo-European conference that we had at the end of the year, we also showcased the artificial intelligence, the blockchain, and the patents and standards for the Internet of Things. So we like to think we're leading the approach globally for what is patentable in these areas, and it's also very important to us as the leading PCT authority that we help to promote this manner of patenting throughout the world. We cooperate very closely with other patent offices, such as the Japan Patent Office, but also through the other patent offices with the IP5. So we do comparable studies on computer-implemented inventions with the US. We're doing it with the Chinese now. We're doing it with the Koreans as well as the Japanese. And the Japanese have done a lot of work on analyzing where things are going. Can you patent big data and so on? They've actually initiated a service for looking at the essentiality of standard essential patents and so on as well. And we would very much like to continue to work with the other patent offices to develop a common IP5 approach to these things, because we're looking at globalization, we're looking at connectivity. These systems are no longer isolated anymore. It's very difficult to define where things are happening in the cloud, and you have to then draft your claims accordingly. And the jurisdiction, the courts, also have to take a view of, not too narrow a view, of the geographical jurisdiction of individual patents and so on. And we wish to work very much with the Indian Patent Office and other patent offices to develop this common approach. So I think, it's more and more global. We have to work with the other patent offices in this manner, and that's the kind of way we're going. So I'll say thank you very much. I look forward to some interesting questions later on, and we'll pass on to the next people.
Thank you very much.